So good afternoon, everyone. I am Steve Colenzo from the Air Force Research Labs Information Directorate, one of the 4 individuals that are running the HAS2 event. And we have this lovely panel of individuals that we are looking forward to discussing a lot of different things regarding commercializing space and talent and skills that you may or may want to have as you look to making space a part of your life and or career. So thank you everyone for being here. We're at the dawn of a new era for space exploration, where at the moment, barrier of entry is at an all-time low, considering where we came from in the 50s. Relatively cheap and ready access to space allows ideas to become reality awfully quick. And it seems as though a commercial space race is accelerating, which can be seen in the billions of dollars that are being invested by both the public and private sectors around the globe annually. So in this panel, Realizing Space Commercialization, Who's Got the Chops? We're going to hear a variety of perspectives on the necessary entrepreneurial vision, technical aptitude, and risk tolerance required to navigate the potential investments being made for future space endeavors for companies, individuals, as well as larger other entities to take advantage of as we move forward in the next 100, 200 years. So thank you so much, everyone, for being here. It's a pleasure to spend the next 45 minutes with you. I would like to start with Mr. Robert Powell, the Senior Advisor for Cybersecurity at NASA, to give a couple opening remarks, who you are, where you came from, and what do you do?
Hey, Steve, thanks so much. So first of all, I'd like to thank the Department of the Air Force for their leadership role in bringing together what I think is an important event. A little bit about my background. I've been operating in some capacity for the last 25 years with cybersecurity. And I have the great fortune of today being in a senior advisory capacity with NASA. My position is within the Office of the Chief Information Officer. And in that role, I work closely with our mission programs, our center CISOs, and our agency leadership team members on a myriad of mission cyber matters, typically in the areas of cyber policy execution, risk mitigation, and risk governance. To add a little bit more context for my role, as you can imagine, corporate cybersecurity is an area where large agencies, large companies have to have expertise. But within entities like NASA, we also have to have cyber expertise on the mission side of our house. And so our corporate side, we handle the traditional enterprise IT services that you can imagine. We have that cyber expertise there. But on the mission side, we also have to have certain cyber expertise that is slightly different from the corporate side of the house. And within NASA, it's heavily focused on our engineering processes, for instance, associated with the life cycle to build out a mission program or a mission asset. So my role was created in 2016. It is an agency leadership position, and this role was created to specifically bridge the gap, if you will, between the traditional CIO's office and our mission programs, as well as our agency engineering office. So excited to be here today. Again, very passionate about cybersecurity, and looking forward to the discussion. Thanks so much.
You're welcome, Robin. Thank you for that. Much appreciated. It's certainly important, the cybersecurity, the cyber hygiene of our space systems. And it sounds like you and your role are certainly thinking of that. So thank you for being here. Next, we have Lieutenant Colonel Daniel Showalter, the Director of Space Systems Research Center. Over to you, sir.
Hi, I'm Dan Showalter, and as Steve said, I'm an Air Force officer. Spent almost exclusively my entire career working in the space community, whether on the research and development side or academia, and then even on the operational side at a combatant command. And in my current role, as Steve said, I'm the director of the Space Systems Research Center, which falls in the Department of Astronautics at the United States Air Force Academy. And my role is really to implement our department's motto of learning space by doing space. And what that means to us is that we actually provide cadets the opportunity to design, build, integrate, test, and operate real-world satellites. And we currently have 2 on orbit right now, working on a 3rd. So the cadets get the opportunity to work on the engineering side of the house in the development of those systems, as well as the operation and analysis once those systems are on orbit, and how do we provide data to our AFRL sponsors. And that's all I have. Thanks, Steve.
You're welcome. Thanks for joining us. Appreciate the intro. Next, we have the CEO of Atomionics, Mr. Sahil Tapiawala. So please, sir, let's hear your background and what you're doing with this company.
Thanks, Steve. To briefly share about my background, I absolutely enjoy working at the intersection of technology and science, and later finance as well, to be honest. And this has taken me to interesting roles and projects. I have worked on biomimetic robotic stingrays as a material scientist, as well as a control systems engineer. Furthermore, it has also brought me to helping deep tech companies in Singapore fundraise and hire the right team, and beyond that, understand the world of venture capital through a stint in deep tech VC and accelerators in Singapore. Currently, I dedicate my waking hours to building quantum sensors to measure gravity at Atomionics. Atomionics is a VC-backed startup, and we use gravity to create an X-ray of the Earth's crust. Now, this has some incredible uses as well. One can exactly pinpoint oil and gas reserves and mineral reserves to democratize access to energy. Beyond that, it can also be used to identify underground infrastructure, bunkers, tunnels, etc. We extend the same technology to navigation systems as well that work in completely GPS-denied environments. But what really excites us at Atomionics is the fact that we can build a completely new GPS or global positioning system. Our sensors can measure gravity so precisely and in such a way that we can create a unique fingerprint of any place. And using that fingerprint, we can position ourselves anywhere in the world, be it underwater, underground, and even in space. And that's essentially what excites us. And I'm quite glad to understand more about HAS2 as well, which operates at the intersection of, again, physics, cybersecurity, and computing platforms. Thanks a lot. Over to you, Steve.
Sahil, thank you so much. It's interesting to talk about GPS, and hopefully we can revisit that later, because the unique thing about it is it's not just latitude, longitude, altitude, but there's that 4th dimension of time, which is really important as we use it and leverage it in devices and applications. So hopefully we can visit that. Thank you so much for being here. Next, we have Mr. Gabe Mounts, the Deputy Director of SpaceWorks. Thank you for joining us, Gabe. Over to you.
Hey, thanks, Steve. I am with the Air Force Research Lab Space Vehicles, technically, and recently became a Space Force civil servant, where for a while I've been doing a lot of space research, but probably the last 4 years or so, I've been doing work in accelerating solutions from the non-traditional industry sector, otherwise known as the startup sector, towards the mission sets that we have in the Space Force. That whole activity, what we call the Space Force Accelerator Program, is now being integrated into SpaceWorks that we just stood up a couple of months ago. And for that reason, I'm now the Deputy Director of SpaceWorks. For SpaceWorks, we will operate the space funding line for all SIVers and SITRs going forward. We are the space arm of AFWorks, and we will continue to run a number of programs underneath SpaceWorks, including the accelerators. One of the other major programs that I recently became in charge of, I co-lead the first space prime effort under SpaceWorks that we're calling Orbital Prime. And we're intending to prime the pump on the nascent commercial market of on-orbit servicing, assembling, manufacturing toward a demonstration in 2024 of active debris remediation. So we're really trying to push the envelope of where the market's going in space, and I'm happy to be here.
Excellent. Thank you. We're happy to have you. It's really cool, though, that the government is starting to look at these small businesses, as we call them, non-traditionals, because they might be startups, and it might be a little difficult to understand how to work with the government, especially when it comes to the space domain. because as far as however many years ago, let's say 10, it's not regular that you see all these startups in the space world like you did in the internet, and then application companies, whether it's platforms as a service, software as a service. So there's unique opportunities out there to do what these companies really want to do for both the public and private, and what we call it, and we refer to that as dual use technology, which is really good. It's good for the globe, and it's good for, I think, for the space world as well. So thank you for being here, Gabe. And lastly, we have Mr. Eric Truitt, Chief Solutions Officer at Terran Orbital. Thanks for being on this, Eric.
Yeah, thank you, Steve, HAS2, and the Air Force, for the opportunity to be here today. I am recovering from laryngitis, so if my voice squeaks like a teenage boy, you'll know why. I'm the Chief Solutions Officer of Terran Orbital. If you haven't heard of us, Terran's a U.S.-based, U.S.-owned and controlled manufacturer, owner, and operator of satellite systems and other space-based solutions. We provide Earth observation data and analytics to defense, intelligence, civil, and commercial end users. Terran's built on the success of two subsidiary companies, Tyvek Nanosatellite Systems and Predisar, and we basically went from a garage-based business about a decade ago to recently announcing our intention to become a public company early in 2022. My background to get to become a Chief Solutions Officer is I've spent the past 21 years mostly on the collection and analysis side of the intelligence business. I started off in the U.S. Navy, where I spent 5 years as a cryptologist before entering the private contractor world. Early in my career, my specialties were in satellite communications, cybersecurity, and RF signals intelligence. However, my career evolved into more of developing operational prototypes, both the hardware and software systems and applications to solve the top collection and analysis challenges for the intelligence community and the Department of Defense during the campaigns in Iraq, Afghanistan, and across the globe. Notably, I ended up at Georgia Tech Research Institute, not as a pure academic, but in a position where I had the privilege to lead the innovation and strategy for solution development for both intelligence and space community sponsors. The diversity experience that I've been fortunate enough to have over my career in both the missions and the technologies that I've worked with has given me this ability to work problems backwards, to really identify the right technology, the right expertise, and the right business approach to developing the right solution, often in, very early in program efforts. So it's a we've heard the fail fast side of, startup culture, but really, you can do that when you have a great depth of expertise and a great set of, connections to the right people who have this vast experience. So it's very important to leverage not just your own experience, but that of the team around you and your colleagues throughout the industry. And this space community is a very tight industry, and we enjoy a lot of the benefit of being able to work together on these problems. One primary solution I talk about that I've developed during my career was a radar technology that we've ended up using here at Terran Orbital as a part of our new Predisar constellation. It's a 96 satellite constellation that delivers synthetic aperture radar imagery and other types of Earth observation solutions with a very high revisit rate around the Earth. But we'll talk more about what Terran is and what our what solutions means to us later. But I have a relentless passion for problem solving, especially in the space domain, and I'm glad to be here to share some of that passion with everyone here today. Thank you.
That's great. Thank you so much for that intro. And you hit on two things that are near and dear to the heart of Hackasat. And that is, when you say looking at things in reverse, it's really backing up that timeline when we start to focus on cybersecurity versus bolting it on in the end, because oftentimes that can go sideways on us, especially as I say us as a globe, as we're utilizing these space systems, not just for a government or what nation state, whatever their purpose originally was, much like GPS and whatnot. So that's the first thing that we're really trying to do at Hackasat and drive home. But another thing is, with the democratization of space, you can start in a garage and become a much larger company, and ultimately, as you said, plans to go public. That's really important for what we're really trying to cultivate here. But we really want to make sure that cybersecurity is upfront with all these solutions, whether they're hardware or software. So thank you so much for that intro. Now I'd like to get into a little more specific technical questions. I mean, not technical in terms of the science quite yet, but just dig a little bit deeper into each individual that's on the panel and sort of how they can shed some light on what we talked about of the goals, especially those two things that are near and dear to Hackasat's heart. So, Mr. Powell, as we look as you in your day-to-day efforts, come across more companies that are either forming or that have been formed, and maybe they're spinning off different business models or different business units that are looking at space. Are you focusing on their attention to cybersecurity? Is that sort of a requirement? How do you actually bound that to determine, okay, this company cares about cybersecurity and they're a startup or they're a medium-sized company, and that's really important? And I'm not saying they'll have a competitive advantage, but just that how do you make sure that that's a focus of what their product or service is? Over to you.
Sure. Great question, Steve. I would probably break that apart into a couple of areas. The first area being companies that are doing business with the government. So I can speak on behalf of NASA in particular. Within NASA, we have requirements and procurement regulations that actually define the cyber controls, the cyber requirements that entities doing business with us are expected to perform. Right. So if we are executing a contract with a commercial entity to build a space asset, we have defined in the contract cyber requirements that must be met. The underpinnings of those cyber requirements come from NIST, right? The NIST 853 series is familiar to anybody working within the cyber domain, and the NIST 853 series is certainly applicable to the space segment. So that's one kind of category that I would consider. The other category are entities that are not necessarily doing business with the government, but they are launching assets into the greater space domain, the space ecosystem at large. And in that sense, there is still a need to ensure that those assets being launched into space are being developed and operated from a risk management perspective. And again, I'll introduce NIST, right? So the NIST series of controls is not exclusively intended for the government. It is publicly accessible, and those controls can be used by private entities as well. I'd like to add a little bit more context on the commercial side of the house. In October, DHS and Department of Commerce hosted a space cyber symposium, and Don Graves opened up the symposium with a couple of comments that I think, again, really helps set the stage. So I'm just going to quote a couple of these data points quickly. One is investment in space commerce is surging, with $5.7 billion in private equity invested in just the first quarter of 2021. The other data point that he mentioned is the number of commercial satellites placed in space is growing rapidly, from 140 satellites launched in 2012 to 1,283 launched in 2020. So again, I talked earlier about the ecosystem, right? As we are introducing new assets into the space ecosystem, management of risk is a priority, right? Not only to the individual asset itself, but also to the greater ecosystem. I would close this out by pointing the audience to a number of resources that are, again, publicly available that touch on the topic of risk management in the space domain. Space Policy Directive 5 in particular is an area of focus that I would encourage anybody to look at that has an interest in this area. Supply chain risk management is specifically highlighted in SPD 5. I think that's an area of growing concern, right? Where do we source our parts from? Not only our flight hardware, but also our flight software. Do we have confidence in the credibility of those components? And I would also mention two other, I'd say, coordination activities in the space cyber domain. One is the Space ISAC. And the Space ISAC works very closely with both DHS and CISA, as well as the commercial entities, to ensure there's awareness of best practices, as well as standards, right? So trying to have consistency in the standards that are being deployed across the space domain. And the last entity that I would mention is the Satellite Institute Association. They represent a number of commercial entities and ensuring, again, that there is broad coordination with the government to address concerns that are relevant to the commercial space.
Okay, gotcha. That was a lot. Really excellent to put that all into context. But what I think I'm hearing is the risk tolerance of putting hardware and software into space is a lot lower than, let's say, the analogy of the internet in its beginning days, where you could throw up a web page and it might have a lot of holes in it, and it was really never a hygiene aspect to it. But now, as we know how serious things are and how fast these objects move up in outer space, tolerance for I don't want to say mistakes, but making sure the hygiene is good is really it's important. So I would say there's low tolerance for those types of things, and that's what you're focusing on.
That's exactly correct. And I may have misspoke earlier. It's the Satellite Industry Association as the other key coordination piece, right? So yeah, you're exactly right. I guess I would close it in saying that the threat landscape is evolving, right? 20 years ago, we didn't necessarily have to deal with the element of cyber threats that we do to the space industry today. So much as the cyber risk landscape is evolving, we have to evolve our practices as well to ensure that we can operate safe and effectively in space.
Gotcha. Loud and clear. Thank you for that. Which is a really cool segue, because cyber is one thing, space is another. They're definitely connected 100%. You really have to understand both, from all the reasons you just mentioned and the guidance that's out there. But as we look to the education of, and typically how you would get into the space world if you wanted to pursue an education in it, what do the curriculums look like and whatnot? And that brings us to Lieutenant Colonel Showalter. So, sir, as you look at, or as you teach and understand what it takes to operate, understand, actually do anything in outer space, you said the motto was learning space by doing space. So currently, if you take a snapshot of the, let's say, astronautics department that you run, has the educational or the curriculum aspect of learning by doing, has it changed much from when it started? Let's say, I don't know exactly when it started or when it formed at the Academy, but when it started to where it is now. And do you see that evolving as cybersecurity becomes more of an inherent thing that needs to be looked at no matter what you're doing?
Well, what I would say, Steve, is that the fundamentals to space, the space domain, engineering in space, whatever that is, those aren't changing. I mean, the physics doesn't change. So what we look at and what we teach is going to be very similar to what was seen in the past. What is changing now are really the applications. So what you can do in space, and that's driven by cost. It's become much cheaper. It's driven by different phenomenology that it becomes affordable now to detect from space. So I would argue that the fundamentals aren't changing, but what we need to do a better job of communicating to young people is the opportunities to get involved in space, regardless of your discipline. They're available. And what I think about a lot now is decision making. So we have long collected data from space and used that to inform decisions. What we as a community are trying to do now, whether it's in business or government, is make decisions faster. So you can incorporate things like data analytics, and those types of folks, they haven't always been, I don't want to say, they haven't been necessarily aware that they have an opportunity to participate in the space community. And I would say the same thing from a cyber perspective, whether it's machine learning, AI, all of those things can be applied in a space context or a space application. And that's really what I think we need to do a better job of from an education standpoint, is communicating those opportunities that are available. I mean, we're always going to need electrical engineers, mechanical engineers, physicists, the whole thing. And their fundamentals, they're not changing much. I mean, yeah, the things are improving. What we know about teaching is improving. Even what we know about phenomenology is improving, but the fundamentals aren't changing. So all that to say, I think we just need to do a good job of incorporating all these other disciplines into the space community.
Okay, cool. And that's kind of what I was getting at. So do you see that evolution actually happening with textbooks and the hands-on learning where you are incorporating opportunities to use or data analytics, data mining, let's say artificial intelligence, machine learning, and or quantum information sciences into in space and how they relate? Because I think if you zoom out, if you're really, really focused on the space world, which is hard, right? I think you might admit that those physics, yes, they're physics and they're science-based, but they're different up in outer space than they are here terrestrially. And calculating all that stuff isn't as straightforward as some of the equations that we did learn if we only took, physics maybe a couple different times in college. So do you see the curriculum evolving where you are, not you, but the community is including these other disciplines so that you're learning them side by side, but not necessarily becoming an expert in them?
I think that's a tough question in the sense that I look at the people that I've worked with in my career, and you have people that are really, really smart in orbital mechanics that couldn't put two pieces of hardware together. I mean, if they would end up in smoke if they tried. So what I love about the space business is it's really the integration and synthesis of all these different disciplines that can be tied together. And I think it's difficult for one person to be able to take all of that knowledge and incorporate it into a single brain. But what's great is you can incorporate a team where you have expertise in these sub-disciplines. So I don't necessarily think that it's necessary to integrate cyber education with space education necessarily, but it's really making the folks that are working on the space side aware of the importance of cyber, and the folks that are working on the cyber side aware of how they can contribute in the space domain.
Perfect. That totally makes sense. And I completely understand. You can't be the one person that knows everything, but at least if you're aware and you understand how the different disciplines impact space, then you can, if you're a company or if you're part of a team in a company, you can assemble the right team. And I think perfect. And I appreciate that insight, which I think really marries well to Mr. Tapiawala's company, as well as just understanding that I believe you have some multidisciplinary teams in what you're trying to do. So if you could, I'll ask you a couple different questions, but the first one sort of piggybacking on the Colonel's comments. How important is the team you've made up, or whatever you plan to do in the future, how important is it to have those different disciplines and have each of those disciplines not necessarily worried about one another from an expertise level, but just that be aware so that they can contribute in this sort of give and take as you sort of develop products?
Absolutely. In fact, I was planning to chime in on that as well, because Lieutenant Colonel Dan really mentioned or hit the point on its head that you don't really need to know everything about a particular topic, but you need to know how other topics also operate in the context of the project that we are trying to implement. So for example, when we work on making quantum sensors at Atom Ionics, we have quantum physicists working extremely closely with electronics engineers, as well as mechanical engineers and software engineers to build a product. So this is not just a physics experiment, or it's not just an electronics product or a chip that we are building, but it's a combination of it all. And I think what has really tied our team together is the appreciation for where the other things fit into the puzzle that building a quantum sensor is about. And I think that's a question that we always get asked, as well as at the intern level as well, that even our interns end up contributing massively to quantum sensors, and they come from a background in, say, engineering or physics, but they know a specific topic in, say, mechanical engineering or electronics engineering, but you can carve out that part in a quantum sensor, and they can contribute that and then also understand how that fits into the whole setup. So I guess it's important to just understand the context in an interdisciplinary team, and I think that's where team composition becomes quite critical, and just an appreciation for other domains as well.
Excellent. Yeah, no, I can certainly see where that makes sense, and that's a perfect piggyback on what the Colonel said about the different disciplinaries and understanding and sort of that education of not having to know all of it. But now, can you speak a little bit about what does that mean when you're looking at the business side of things with venture capitalism? Because I'm assuming, and I could be totally wrong, and please tell me if I am, that probably is very, very different from orbital mechanics or quantum sciences. But speaking to a venture capitalist, understanding what they care about, and ultimately getting funding from them so you could actually have that capital to start a business, hire individuals and whatnot. I'm assuming you have to have some chops in that world as well.
I guess that's also one of the ways to identify who the right partners would be at the financing level. So, for example, in our case at Atminix, we are quite fortunate to have investors who are aligned with the technologies that we are building, but more so importantly, they are aligned with the way that the markets are developing. And I think just as is the case with different engineering domains as well as with different domains in physics, there's also an aspect of business development and finance that one needs to understand. It is just another domain that comes into the picture in a startup. And so one of the key things that I guess we had to really improve our mental model on was how do the markets fit into utilizing quantum sensing or the technologies that we are building. And especially in conversations with, say, financiers, investors, or whoever that doesn't come from an engineering background, I think it's to start off with the topic that interests them the most, which is how big the market can be, what are the how fast growing is the market. In addition to that, what are the use cases that this completely new technology enables? And I think that's what's attractive to a lot of investors as well, who are entering this domain in droves, to be honest. So in fact, there's also quite evident through the amount of deep tech venture capital investors that have come into the picture, who not just look at this from a perspective of what is your revenue growth rate, but what are the completely new markets and technologies that what are the new markets that new technologies can enable, and which is a completely new way to look at venture capital financing.
Okay, got it, totally. And I think that weaves a really good thread through the fact that when you look at the title of this panel, commercializing space commercialization, realizing it, and who has the chops. It's really anyone. So if you look at outer space, encompasses the globe, right? It surrounds the Earth, and that transcends to the technology and the capabilities that are up there, because you really can come from any different discipline, put your expertise to work, and be in the space world if you so choose. So really good, all great points, which I think also piggybacks nicely to introducing Mr. Gabe Mounts when it comes to the space works, as you mentioned, working with the government, if it makes sense, but opportunities for small businesses who don't have a ton of capital and are a full staff of, let's say, multiple mechanical engineers, orbital physicists, and whatnot. But do you see any trends of where a lot of these companies that are forming are focusing on, whether it's quantum, AI, ML, all the buzzwords you would expect, sort of what the kind of Colonel's hinted on, where all these other disciplines, you need to be aware of them. But do you see a lot of companies marrying those together, or are they just purely space-based and they might get interested in the other disciplines if you mention it, or some of the feedback they get on their proposals or whatnot?
Yeah, so a lot of the work I do is really looking at markets, right? It's understanding where the markets are going, especially when it comes to space, because that's where I'm busy tech scouting to understand what capabilities are being created in that private sector that we can maybe glean or maybe somehow bring to bear for our mission purposes in the Space Force. Probably a lot of people on this panel would agree that we're in what it's being called the second space age. And that's largely because access to space is much cheaper. The launch costs have come significantly down. And so you see a lot of companies, a lot of startups, if you will, entering into the market with hopes of becoming rich. but you're also seeing that because there's a lot of venture capital pouring into the market for the same purposes, to develop a profit. And ultimately, everybody's trying to somehow derive value from the space domain. Some estimates I keep seeing, 5 to 10 years from now, we're going to see the market at $3 trillion. And it seems to me, in the scouting I've been doing through SpaceWorks and through our accelerator activity, everybody that's traditionally been focused on a terrestrial sector of some sort is now trying to understand, can they translate that terrestrial sector capability where they're currently trying to derive value and now derive additional value from doing whatever it is in space. Most market trends will show you that the main commercial or consumer market for space is still going to be remote sensing and connectivity. But increasingly, we're seeing things like increased bandwidth and essentially internet, the terrestrial internet infrastructure starting to make its way into the space sector. So you're just going to see the translation of the whole internet infrastructure into space, and space and terrestrial being combined essentially into one big supernet, if you will. So anything that engenders that, and AI and ML in particular, more onboard computation. Satellites we're starting to see a lot of companies bake a lot of high capacity computation into their satellites, something the government traditionally shied away from because we were fielding systems for the long term. Now the access to space is so cheap, people are just trying anything that they can get their hands on and flying it into space. So with things like increased computation comes the abilities to do more onboard ML, perhaps more AI attempts, and then all the associated vectors for cyber that's related to come into play. So I think that connectivity layer is going to extend. You're going to see a lot more of that. Plus what we heard earlier, the data science, the data analysis, all the data fusion things that you're going to see out of that. A lot of work being done on the way that you actually transmit data in space between the space nodes, the assets that you have there, that's going to grow. And so there's going to be a cyber element there, perhaps also with quantum baked in for security. And then that higher onboard computation, a lot of us on the government side really want to drive things in space that will help us contend with the resiliency we're seeking due to the congestion, right? We're going to see tens of thousands, if not more, of assets in space very soon. It's getting very congested up there. And so a lot of folks are working on how do you enable the satellites to work on their own, to be resilient, to maneuver around that congestion, and how do you do other things in the situational awareness domain so that you understand how to maneuver your satellites. That's all coming very quickly, leading to what we think to be the next perhaps wholly owned business to business market, which would be this idea of logistics and servicing. How do you enable our mission sets up there to be extended? Ideas like refueling, onboard assembly, onboard manufacturing, onboard repair, that kind of stuff we're going to see coming down the pipeline very quickly. And I think that all hinges upon advanced computation and the data layer that needs to be supported, which all then leads back to the cyber you're going to need to bake in to enable that to be happening without much incident.
That was a lot. That was a lot of great insight, and I appreciate it. But I can completely understand and appreciate all those new, I don't want to call them a new market segment, but it might be a new market segment for space. Obviously, we do logistics here on the ground for many different things. Multiple companies do it in a different fashion for various reasons. But as that transcends to space, really good, a lot of good light shot on that. So thank you for that. So now over to you, Mr. Truitt. First off, it sounded like you said Terran Orbital, more or less cradle to grave, space vehicle, software, hardware development. But as a solutions officer, what are your responsibilities? And I'm asking this from the lens of, okay, well, maybe I've been in a C-suite in a company, or I started my own company, and I think I have the chops where I have whatever technical background, and I want to contribute to the space world, and of all the reasons Gabe said, and all the things Sahil and everyone's been speaking about. So what does a solution officer do?
Yeah, well, first, I mean, it'd be great, just to talk about solutions. Solutions are about empathy, right? Truly understanding what your customers' challenges are, but also how does that challenge actually affect their mission and their business? And then, second, solutions are enabled by capabilities, people, and a business model. So it's not just any one thing. And so, earlier I talked about, my experiences, my background, and some diversity across the use cases and technologies. But also there's an academic perspective to this. We think a lot about technology and going into engineering and science programs, and those are certainly, keystone elements, in the technology field. But also, think about, getting an MBA, right? I got an MBA later in my career, because what you become to realize is that every innovation, every research program, every new idea is a startup in its own. Even if it's not a proper separate business, even within a company, it is like a small startup. So you have to have not just a great technology, not just an identified use case, but also some business knowledge about how that idea can be supported by revenue or some kind of funding. And so there's a holistic aspect of solutions, which is really imperative in each company. So in my role as Chief Solutions Officer, my job is to be a supportive leader, both to the team of subject matter experts that work across a variety of solutions areas, which can be technologies or applications that are on my team, but also to my colleagues and the other executives and managers in the company that run other business units. So really, if we take a business and let's simplify that into two categories, you look at profit and loss and really your execution portion of your business. So you think about business activity and perhaps engineering production, right? These aren't completely disparate or siloed areas of a business, because they're typically, functionally matrixed across different programs or different customers. But where solutions comes in is really to promote success in those business areas, in business units within the company, and the overall corporate objectives, by focusing on delivering the right products, the right service solutions for the customers that work within the company's business model and financial objectives, right? So my team, we accompany the business development, the account managers, doing the customer facing activities. But we also support our execution teams and production engineering by providing subject matter expertise and bringing that customer voice and bringing the customer challenge and problem to those product development teams and those engineers and folks who are doing the development there and integrating systems or providing services. So honestly, in solutions, there's really not a dull moment. It's very rewarding, because you get to work across all aspects of the business. And many companies now in all areas of technology, but specifically in cybersecurity, with dynamic challenges, with dynamic problem environments, they're adopting this approach of delivering solutions rather than just a widget or a product, right? Because having that empathy with a customer is really critical to solving the problems, with the right solution, not just hoping that the shoe fits, every size foot, right? So it's a really exciting time to be in technology businesses.
Thank you for that. I think that's really important, the empathy aspect, because when we talk about resilient space systems for the globe and all that we rely on them for, it does make sense to look at the person first, the customer first, from an empathetic standpoint, because our everyday lives are affected by space, whether we know it or not, or like it or not. So really, really cool. You answered the other question I was going to ask, but thank you for shedding some light on the solutions officer. What it amounts to really, though, is there's a lot of opportunity, no matter what discipline you're looking into or what you really, really like to do, whether it's something that you've already been educated on or something that you'd like to be educated in. There's opportunity in the space world to do pretty much anything, which really leads to this general question. So everyone can unmute and speak candidly. Is really about, if you look at, we mentioned GPS. We understand that a lot of our applications, even our cell phones, a whole bunch of different things use it. Other governments use it for various things as well. You look at the internet, that was not intended, what we use it for now wasn't intended when it was developed for that exact purpose. We got Web 1.0, 2.0, and 3.0. We have this metaverse thing happening. So that's sort of moving in a direction. We also, as people have been mentioning, we have internet in space, offering internet for disadvantaged areas that are denied essentially from having the infrastructure that normally is in a largely populated area to have internet. So will there be a next big capability? And I'm going to use GPS, even though it's overused a lot, and the internet. Will there be something like that in space that, or do you think, so it's a candid opinion, do you think there's going to be a next big thing in space such that it impacts our lives so greatly, like GPS and the internet of today?
Yeah, so
I guess I'll go.
Dave.
I'll go ahead.
Well, I was going to say,
One,
back to the earlier point, someone made about moving the internet kind of paradigm into space. I think, obviously you need the highways and you need the storage centers, right? So more communications and more data centers, data services in space. I think that's going to emerge very soon as capability, as infrastructure. Space is an element of infrastructure. And I think from a national security perspective, for any country, when they look at their infrastructure, space will get added to that list of utilities where where there's a key desire, key need for it, as we've seen, like your point, GPS, but then that need to protect that. So as part of a national defense strategy, even countries now that had not traditionally been space players are going to have to do that to protect their national sovereignty and their country's infrastructure on the world stage. Sorry, Gabe.
No worries. Yeah, it's always like that, right? When you have these big panels, is who goes first? I think tacking on to what I was saying before, certainly what I'm seeing as a potential kind of new market for space is this whole servicing aspect. And I think I kind of described that a bit, but we're also perhaps seeing, and maybe don't even know quite yet how this is going to formulate, as the private sector and as the nation states move out to our extraterrestrial bodies to do things. And I'm not certain that those particular markets, I've seen plans for different things. How do you derive value essentially from the moon, for instance? How will Elon eventually derive value from Mars? Regardless of what you believe as to if that's actually going to materialize or not, there's definitely going to be the attempt to do so. And so I think you're going to see some new markets forming on enabling how do we essentially create these new traffic lanes out to those terrestrial bodies with all the potential private sector, even nation state entities pushing assets out those ways. I think that's going to be a big potential value stream for somebody who can unlock it.
I just piggyback on that because we started talking about space exploration as well. And I think over the next 50 to 60 years, I do take a more greenfield view of this, that I think that's going to be a completely new black swan event that could potentially happen as humanity becomes interplanetary. There could be completely new economies that might evolve. For example, what we are personally quite excited by is as we put these quantum gravimeters in space, you can essentially model a particular planet directly from space itself. And by model, I mean go one step beyond just imagery, but also just how the planet evolves. Now, how can that be applied to, say, other planets? For example, on the moon, you can identify lava tubes, you can identify the structure of the moon. The same goes for Mars as well. And I think these are kinds of things that that even other satellite platforms or remote sensing platforms might unlock. In addition to that, there's also a massive push towards putting factories in space, and I do believe that that would be quite interesting in terms of just having microgravity, having structures and materials that really use the microgravity environment to completely change how we build things. I think that's going to be another interesting domain which will evolve, and which I think it's hard to predict how it will evolve right now. But there will be a lot of new science and engineering that we can sort of build up a completely new economy on. That is personally my view.
Really good insights. Thank you, everyone, for that. So, but I want to get back to the academic portion of all of these different sciences and knowledge that you may need to pursue something that we've all been talking about, whether it's a new market in space or just in space. I've seen over the years since me being in college that there's been all these new degrees that have arisen, and from reputable institutions. So given, let's say, fast forward 20 years, even 50 years, does the panel, do you think there's going to be new degree programs that don't necessarily make you an expert in space, cyber, or any one discipline, but it has historical knowledge and capabilities that have already been launched and are being used, whether it's a service, something logistics wise. Do you think there'll be new degree programs that people can take advantage of and learn about? So not like, again, they're not the expert, but they come out with a really robust knowledge of what it really takes, what are the chops that you need to do something in space?
Well, Steve, I'm going to assume that question's for me, but to be honest with you, I'm going to fall back on my previous answer. I don't think the fundamentals are changing. I think fundamentally you need to have a background in whatever discipline that you have. What I think is interesting now, and maybe this is where you're getting at, is the opportunities for anyone to integrate electronics, for example. It's out there. There are very low cost solutions with Raspberry Pi or Arduino, where young kids, even before they get to college, can get experience with hardware and integration and developing those skills that you won't even learn through a degree program. So things that you need to actually build hardware, to actually apply something in space, they're tools that are readily available to young people even before they get into college.
Okay, yeah, no, that makes total sense. And I appreciate you shedding light. And that's kind of where I was going. So there's an opportunity from the STEM aspect of things to take advantage of before you get out of high school, before you go into college, and even afterwards. And I think that's going to be important as the globe moves more and more into outer space. So this is the last thing I kind of want to hint on in terms of, we're looking at deep space exploration, when we're looking at putting more humans in space, regardless of the country. Is there a new industry or an insurance aspect of it, like life insurance? But more importantly, I would assume it's life insurance, but now we're also talking insuring very, very expensive pieces of hardware, which are certainly up there now, but they might get more expensive. We look at some of the things that we want to put maybe between the moon and to get to other planets and debris removal and all this stuff. Is there going to be an opportunity for a company or companies to look at it from an insurance perspective of, I'm going to insure this space vehicle for the life of 20 years or whatever, and have a premium and whatnot? And then how does that impact maybe someone's life insurance plan when they are going to outer space? Because I mean, it's probably similar to, it's just as dangerous as if you get on the road nowadays, or you take something in on the sea. But how does the group feel about that in terms of new industry for insurance companies in outer space?
Well, Steve, I'll step in on part of this. I mean, one idea on insurance, you could look at a different approach, which is lower cost and, higher safety, right? Or, higher quality at a lower cost, right? So, I think as more and more in the industry specialize in manufacturing space qualified systems, some of that price that you're talking about to build these really expensive systems. I mean, this is really where the space industry is going now, is to bring those costs down, but assure the same or better quality that those larger systems had. So I think as that trend continues, then from an insuring perspective, investment's a great insurance as well. A good big bank account of cash from a profitable business is a good insurance policy as well. But obviously, there's a human spaceflight aspect that obviously is different than the equipment piece of it, because obviously you're still going to have to maintain very stringent standards and those things to protect against loss of life. But from a systems perspective and building out, even going into deep space explorations, we build gateways. We're going to be investing in things like automation and life support and communications in ways that we can respond to events, to, again, potential safety issues. But I think as we talked about having a breadth across all markets and different industries starting to become, come into space, manufacturing and investment communities and the insurance communities, all of those segments will have to make those entrances and to start to bring this, to really continue to bring this industry more into the forefront of a market or an operating domain, if you will, to use the military speak of this.
I'll pipe in and say that I think that it sort of already is in existence and maybe is still burgeoning and nascent, but but for just the non-manned assets that some companies are flying, there's an interest, especially like I said, with the congestion and the debris issue. How would an insurance market enable, space sustainability from a cleanup of the debris or cleanup of things that are in the way? A lot of questions I know being asked by insurers and OEMs on how does that market work better, more efficiently. So I think that's already upon us, and it's just a matter of how that's growing and how it's going to evolve over time.
Yeah, we might see some unique ways of how that evolves. Ms. Powell, were you going to say something? Go right ahead.
Yeah, I was actually. So, another interesting angle to all of this is space travel, right? And so there are several, I'll say, wealthy individuals that are wanting to colonize Mars, for instance, right? So as we look at space travel in the near term and perhaps, colonization of planets in the long term, what does that look like from maybe a health insurance perspective, right? I think that's an interesting challenge area, interesting study area, as well as just today, as if you book a commercial flight, you can, as a consumer, procure insurance in the event you have to cancel for any reason, right? So to me, those are all interesting angles that would sort of mirror or model what we have here on Earth, but as we expand our our journeys into space, right? Both for just, entertainment purposes as well as colonizing other planets. What does that insurance aspect look like?
Oh, I think you muted. You accidentally muted on that last statement. There we go.
Sorry, I was just, I guess, kind of drawing to a conclusion, right? I think there's a lot of unknowns, and we're still in an infancy stage with some of our, I guess, our space travels, right? We are just now starting to have commercial crews for space travel. We're having, civilian, I should say, crews. We're having individuals that really are not involved with space from a traditional science or engineering aspect, right? We're launching individuals into space for, let's say, entertainment aspects. What are the insurance implications there? I think a lot of that is to be determined, but it's certainly an area of healthy opportunity from a business perspective.
All good points. Totally understand exactly where everyone's coming from, and it makes sense. And all those linkages, there's a lot of unknowns, but increasing the safety, lowering the cost. I think part of that is really, really tightly connected with cybersecurity, making sure those standards are adhered to and new things that come about, and lowering that or making that attack surface a lot smaller. As new sciences, like the quantum sciences that have been around for a long time, but the applications of them, as we start to identify where those can play in space, that's going to open up a new world of things. Even when someone mentioned the analytics, so even when you're looking at analytics in space and what does that mean, everything is really though connected to cybersecurity. But I think what we wanted to prove here, what we wanted to really project is there's a lot of different disciplines you can get involved with, whether it's educational or otherwise, that maybe you can't get at college or higher education, that you need to get just by tinkering on your own and hitting the internet and utilizing it, understanding what's out there. But really, I hate to use the cliche, the world is your oyster at the moment, because there's so many opportunities. And we are at time. I just wanted to thank everyone for their input, their time that they spent on this panel, because what we really want to do is merge again cyber and space for the globe, for the betterment of the globe, and make our lives that are so heavily dependent on space continue in the future. Because I think in the next 100 years, if we were to take a snapshot and we could all put this in a time capsule, things are going to look much different in 100 years with what's up in outer space and how we utilize it. So if anyone wants a parting shot, certainly go ahead and unmute and have at it. But if not, thank you so much.
Thanks, Steve.
Thanks, Steve.
Thanks, everyone.
Thanks again, Steve.
Thanks a lot, Steve. All right.